Hello, my name is Philip Potloff and I lead enterprise strategy for AWS. Today I'm going to share how enterprise customers are using the migration of their infrastructure and applications to the cloud as a transition point to also update their product development processes. These enterprises expect to see speed and agility improvements by using the cloud, and they realize that their own product development methods need to be refactored to take full advantage of the capabilities they are building in the cloud. First, a little background on me. I joined AWS last year after 12 years in several senior executive positions for the automotive platform Edmunds.com. And part of that tenure included moving our entire infrastructure to AWS and shutting down our data centers back in 2016. And despite being a lifelong surfer, I've actually managed to remain employed continuously for 25 years. Today, I lead the enterprise strategy team at AWS, and we're a group of former CIOs and CTOs that have all led large-scale transformations of our companies that included a move to AWS. We come from a diverse background, including former CIOs at Coca-Cola and even the Department of Homeland Security. And now we work with our peers in the industry to help them develop cloud adoption strategies for their own companies by sharing our experiences and best practices. Before I get started, and to help ensure that I'm touching on the most valuable insights for this group, it would be great for me and our moderators to see what is motivating your attendance in this session. So if you're willing, feel free to use the Q&A to tell us what your primary interest is today. Perhaps you're trying to influence new approaches to product development on your team, but are running into powerful inertia that resists change. Maybe you're interested in an overview of the current best practices being used by enterprises, or perhaps how the cloud is actually changing product development today. Finally, maybe you're just focused on pure innovation and optimization. Before we discuss how the cloud changes your product development approach, it's important that we baseline what I'm referring to as modern product development practices. Having worked with dozens of enterprises around the globe from every industry and every shape and size, no two companies have the same definition of speed and agility. So the first thing we'll review are the current development practices that most enterprises are adopting in one form or another and why they matter. Second, the reason enterprises are putting so much effort into adopting these modern practices is the competitive need to move from the rigid and slow to respond to change to an organization that can consistently and perpetually operate at a high velocity with confidence in making frequent changes based on customer feedback. This is also known as flow. Finally, the value that enterprises are realizing in the cloud goes beyond cost savings, with teams that are able to do more in less time and more easily introduce more capabilities in a traditional on-premises data center approach. We'll take a deeper look at how enterprises are changing their approach to product development with cloud-native architectures. So let's dive in. I'll suggest that there are three critical components to modern product development, whether you are in the cloud or not. How you figure out what to work on. Today, design thinking is a common framework for this job. How you organize your teams and plan your work. Agile teaming methods are not new, but many enterprises are just now looking to them for how to break down work into digestible units. And how do you consistently and efficiently deploy changes with confidence? DevOps is at the core of many digital transformations because it is both the technology and the process. Let's start with design thinking, which is really about customer centricity. And that term seems to be a pervasive fixture in any product discussion today. However, too often we have a great idea that we think will be a hit or change the fortunes of our enterprise. And equally as often, those ideas get started and far along in their development before any meaningful customer feedback is sought out. To change that mentality, about 10 years ago, organizations began to adopt a customer-centric development methodology called design thinking. Now that's a highfalutin term, but in plain language, we're talking about user-centered design. And there's a well-worn set of steps to ensure that the customer value and demand is assessed at the earliest possible stage, preferably before large investments or development cycles are initiated. There's a large body of work, both academic and applied practice in this field, but let me share the basics with how this method is most typically applied and how I've used it in my past roles. Because we're talking about user-centered design, the first step is to understand the user or customer perspective. To do that, it's often suggested that you get outside the four walls of your business and experience the customer in their environment. The Toyota production system has a term for this, Genshi Genbutsu, which translates to go and see. Many organizations will find ways to bring the outside in by doing on-site user interviews and testing. Once the customer perspective is gained, the next step is to clearly define the problems or pain points they have. What jobs are not being done for them? Examples of framing problems include statements structured similar to, as a specific type of customer, when I'm doing a certain task, it is hard for me to accomplish this result. Only after you have one or many of these pain points clearly defined, debated, and in some cases validated, should you try to apply solutions. This problem in search of a solution is starting with the customer, instead of the all too common practice of a solution in search of a problem. Also, don't get married to any one idea at this point, since the next step could very well reveal that your idea misses the mark with the customer. Generate lots of ideas that inventively address the customer pain point. Yet another trap that many organizations, whether they're agile or not, fall into is once an idea has been identified, the desire to start building something is strong. However, at this point, you likely don't have any proof of value or demand yet. Organizations that have a consistent flow are good at making lots of small bets and cycling through them as quickly as possible versus a small number of large moonshot projects. To approach product development in this manner, you create a series of small, fast, frugal tests that validate key assumptions, especially those that are the most unknown, but critical to success. In the digital world, these could simply be trapdoor product offers that link to a thank you for your interest. For the new approaches to product development, it is important to get this feedback from users or customers and constantly revise the product based on that feedback. Other feedback comes from testing, from monitoring the product's performance in production, and so on. So it's important that teams have a way to incorporate feedback into their work streams. This is where Agile approaches come in. Agile approaches are based on the idea of learning from experience and taking advantage of those learnings, as opposed to plan-driven approaches where following the original plan is highly valued. Each Agile framework has a way of bringing feedback into its work stream. Scrum allows the product owner to continuously groom the backlog. That is, change it to achieve more valued customer outcomes, with the provision that no changes will be made until the next sprint. XP, or extreme programming, is more about how work items are prioritized. But as each story card is developed, the team receives continual feedback from on-site customers. And XP also really focuses on technical excellence through things like pair programming and code reviews, although those are not exclusive to XP. And Kanban, which is something that I've grown to favor, is a lean process that focuses on quickly finishing individual work items before moving on to the next item. As each item is finished, a new work item can be pulled into development. And you have very efficient measures like work in progress limits and cycle time metrics that can be evaluated across a number of teams working on very different projects. And Kanban has been used most frequently, in my experience, to to achieve, measure, and baseline flow in an organization. One of the hardest things we have seen companies experience when they transition from an old water style development practice to Agile is the idea that every bit of functionality is not minutely scoped, and at a surface level there can be seen to be very little specificity or direction. Some folks on the team embrace the change and declare there can no longer be any deadlines because we'll release when ready, and we only scope work in progress on a sprint by sprint basis. To ease that pain, using things like release maps can be a great middle ground to ease minds on the team that crave more certainty, but also enables the team to begin to work more in the sprint to sprint mode. Release maps are made up of epic stories that are big chunks of deliverables, working functionality, and very rough estimates of when each can be done. You put all of these epics together and build a map of weeks or months for that target project. Small teams, lots of reasons for it, but if you've ever managed a big team, you know what comes with that. More structure, more overhead, and less focus on individual units of functionality. Once a team scope becomes big enough, either due to success or a delivery target, the best practice here I've seen is Amazon's two-pizza team concept, where projects are broken up into smaller primitives. And I'll share more about two-pizza teams at Amazon in a few minutes. Every time I've stepped into or been involved with a project that is struggling with delivery, or in the early days of adapting to Agile, one move that has always had an impact was to set an expectation for a demo of working code at the end of every sprint. It worked especially well with executive participation, but even peer pressure on the team was effective. Teams suddenly got better at breaking up work into stories and completing them, and also not overcommitting to work. And as teams mature in their learning and application of Agile, a common stumbling block to moving to more advanced Agile principles are team members that still try to apply the rigid Agile principles without evolving and transcending the core rules. You might hear things like, Agile means taking any new requirements anytime, or you can't incur any technical debt because continuous focus on technical excellence does not allow for that. Every organization is different and needs to find the right balance of best practices and practical realities. One compromise I made that was successful for many years was the maintenance release or feature holiday, where technical debt incurred was addressed one sprint per quarter. I wouldn't say product managers loved it, but developers did, and product teams ended up using the downtime during the maintenance release to refine their own backlogs. DevOps complements those Agile methodologies in the sense that it creates a fast way to deploy each capability when it has been developed, so that feedback can be obtained quickly and routed back through the process. It does this through extensive automation and by eliminating handoffs between silos, in particular, the handoff between development and operations. Code is generally instrumented to provide feedback once it makes its way into production. The heavy automation allows the team to focus on product and feedback rather than testing and deployment mechanics. DevOps also facilitates setting up automated guardrails to manage security and compliance. And with these guardrails in place, the teams can move even faster without adding risk. This too allows them to focus on product and customer value. So DevOps provides mechanisms for fast feedback, and the Agile frameworks provide mechanisms for inserting that feedback into workflows. Continuous integration and delivery pipelines, which are the technology part of and process part of DevOps, are really here to stay, and they're essentially the new factory floor where we build things that process, understand, and secure our data. Continuous delivery is a software development practice where code changes are automatically built, tested, prepared, and released to production. According to the Puppet State of DevOps report, teams that employ DevOps have a 5 times lower failure rate and a 440 times faster time to deploy from commit, and 46 times more frequent deployments, and most importantly, 44% more time spent on new features and code. Setting up these automated workflows is essential to getting agility. And at Amazon, we actually switched to small DevOps-like teams that each own their own microservices and typically practice CI/CD. As a result, by 2014, we had reached 50 million deployments per year as a company. And we also wanted to share this capability with customers and enable them to more easily adopt CI and CD processes. So we've taken our own builder tools and developed an externally facing version known as AWS Code Suite. Once you find flow, your teams will never want to leave that state, and they'll do anything to get back to it. The Agile principles of implementing sustainable development practices and maintaining that pace indefinitely are important objectives for enterprises to achieve in order to keep pace with rapidly changing business needs and the mandate to be competitive. Next, we'll take a closer look at a few techniques that work within our design thinking, agile teaming, and DevOps frameworks that optimize our efforts to move quickly, minimize overplanning, and keep customer need and feedback at the heart of our product planning and development. Feedback is essential throughout the product lifecycle, as we've discussed. In the Lean Startup, Eric Ries points out that when we start to design and create a new product, we don't really know what product will create value for customers or accomplish the business's objectives. Instead, we start with hypotheses, 2 hypotheses in particular. First, what product capabilities do we think will add value for individual users? And second, what capabilities will cause many users to use the product? In other words, will allow the company to grow the user base. As good as we might be, we must still test our hypotheses and decide whether to stick with them or change direction. He talks about building minimal viable products, or MVPs, to test these hypotheses. The concept of an MVP is often misunderstood, sometimes confused with the old notion of version 1 of a product. The purpose of an MVP is learning. Ries gives examples of MVPs that are simply concierge-like products that don't actually function behind the scenes, or simply could be a link to a new product that thanks customers for their interest and offers to give them feedback. The old style waterfall approach lent itself to organizing IT into projects. Projects that have a defined cost, schedule, and scope, and they start and they end. But this model doesn't work as well for Agile and feedback-centered product development, in which plans need to change as there's always a roadmap or backlog of potential future work determined by the customer. For many organizations, it makes much more sense to organize around product teams rather than project teams. The product team is responsible for a specific product and can engage with customers and users to develop and refine a product roadmap. It is understood that work might continue throughout the lifetime of the product rather than having a defined end date. My colleague at AWS, Mark Schwartz, in one of his books, A Seat at the Table, IT Leadership in the Age of Agility, talks about a third model, which resonates with many organizations. In this model, a team is responsible for a particular business goal tied to the company's strategy and is usually represented by a KPI, or key performance indicator. The team includes business people and technologists, and their only official goal is to maximize that KPI, which they can do through creating software capabilities, re-engineering business processes, and anything else that works and is legal. And they might touch multiple IT products or even none at all. A few things that might require explanation on the business objective or KPI approach. While projects have an end date and and product teams have no end date unless the product is discontinued, objective teams take a different approach. They continuously monitor their KPI and stop working only when their KPI reaches a threshold or plateaus out. In other words, when there's no longer a good business case to continue investing in that outcome. Impact mapping is a technique described in a book by the same name by Gojko Adzik. It provides a way for managers to help the team brainstorm on possible approaches to running KPI-based teams. It's important to realize that in the new product development approach, feedback is continuous. It is very different from the old models where feedback was received during a user acceptance test and where possibly a single prototype was built at the beginning of the design process. In the old model, testing was done just before the product was released to production. After that, the only feedback was from defects discovered by users. How many of you here listening today have too often experienced the critical blocker that only surfaced during integration or final deployment to production when it's usually too late to fix it the right way? Can you say technical debt? So a bunch of heroics and workarounds occur in order to meet your release plan. In the new DevOps model, testing and feedback stretch across the entire lifecycle, providing ongoing feedback that informs the product's direction. Even while the system is in production, feedback continues, providing so-called testing in production. Security and compliance are also continuously monitored. Results are measured and tweaked through dashboards for everyone to see, and policy is enforced continuously through things like config rules, and chaos monkey tests continuously test the resilience of your application. There are a number of things that we think make Amazon a unique place. We like to call it peculiar. Our hiring process, our scaling mechanisms, our writing culture, and organizational design, to name a few. But there are definitely some things that have contributed to Amazon being able to establish and maintain an incredibly fast pace for many years now, or flow. And I'll spend a few minutes on each of these. Our working backwards process, our two pizza teams, and our microservice architecture. Every idea at Amazon that gets approved, large or small, is based on a paper. We call them 6-pagers or narratives. And because the expectation that all of these ideas start with a customer need, we call the process working backwards from the customer. This includes AWS itself, a paper that was created by now CEO of AWS, Andy Jassy, but also Amazon Prime and every one of the 125 plus cloud services that AWS now offers. Most of the ideas start out with a press release that is written as a leap into the future and imagine how you want a customer to feel and what you want them to say when they experience the product. When you write the press release, you imagine that your customer is going to read it. It's a one-page narrative explaining your vision using customer-centric language. It's also important that it is in plain English without any internal jargon. The next step is building a frequently asked questions, or FAQ, that accompanies the press release. The FAQ has two sections, one for the customer and one for the internal stakeholders. You need to ask the hard questions, even ones you may not have an answer to yet. Often the press release is shared first in order to understand the questions that come up from reading it. Often a visual mock-up or user interaction guide will be part of this early review and feedback process. But the fidelity should match the maturity of the idea, so rough mock-ups and sketches are okay early on. There's a great all-hands video of Jeff Bezos being asked by an Amazon employee if the working backwards process is mandatory because it seems like a lot of work. Jeff laughed and said, "It's not mandatory if you can develop a better way. And after you've tried the working backwards process many, many times in order to learn how and why another way is better." He finished with this quote, emphasizing that the process most often used in product development today is actually the one that's backwards. Working backwards is how Amazon decides what to work on. How we work is an organizational design that I mentioned already called two pizza teams. On the surface, our teams are pretty typical in that we have managers, TPMs, and engineers in a standard functional hierarchy. But whereas most organizing models are designed to facilitate communication, Amazon two pizza teams are designed to minimize communication among teams and individuals. A team of 6 to 8 individuals that can sit around a table and share two pizzas can communicate incredibly efficiently amongst themselves. And not only are the teams small, but they are also comprised of all of the skill sets needed to accomplish their work without relying on outside teams. If the team doesn't need to talk to anyone, then they don't have to wait for anyone to get their work done. And this eliminates a huge element of coordination and communication overhead. One last characteristic of two pizza teams is that you own or run what you build, meaning there's no handoff to QA or operations upon completion. This is most closely aligned with the product model we reviewed. To enable this work model, the most compatible technology architecture is what we now refer to as microservices. However, Amazon did not always have a nimble service-based architecture. And like a lot of AWS customers that are now moving from monolithic application stacks, Amazon was once burdened with a rigid and slow monolith requiring extensive integration and deployment coordination, with set release schedules and the need to scale a single massive application. In a microservices architecture, applications can be broken down into many small components, each of which can be developed, deployed, and scaled independently. Packaging and deployment of microservices is also much easier using a common toolset and allowing individual teams to release updates when they are ready, as opposed to coordinating with a central build and release team. Today, if you're building a new app, you are very likely to build it using a microservices architecture. And if you're doing that, you're likely using containers or serverless architectures. More than a decade ago, Amazon took our monolith and broke it apart into several services, in fact, thousands of services. And we refactored each app into small, focused, single-purpose services, which we call primitives. For example, we might have a primitive on the product page for calculating taxes or adding items to your cart. Each primitive was packaged as a standalone service and got an HTTP interface. These building blocks only communicated to each other through these web interfaces. This created a highly decoupled architecture where these services could be iterated on independently as long as they adhered to their web service interface. The result has been thousands of microservices at Amazon, with two pizza teams managing their roadmaps. So far, we've covered the foundations of modern product development and how to establish a flow of value creation that can keep moving at a rapid rate indefinitely. We also look at how Amazon applies its own version of these principles. Now let's turn our attention to how the cloud is elevating the impact of these standard concepts with customers. In the area specifically of reducing the cost of failure and experimentation, the rapid adoption of new capabilities, and finally scaling the winning ideas quickly and efficiently. Agile provides a wide range of vehicle telematics services to the automotive, insurance, and finance industries. Agile created the Mile Up driver app and used crash prediction models to speed up emergency response and save lives. The Mile Up app is a great example of reducing the cost of experimentation because it used a cloud-native serverless framework So the small team assigned to the product development was able to focus on the product spec and features and not the underlying infrastructure needed to run it. It worked well for them as they were able to go from concept to product in just 8 weeks. Because they weren't sure about the demand for the service, not having to spin up and maintain a bunch of infrastructure that may not be needed is one of the benefits of product development in the cloud. Only a minimal upfront investment was needed. That was only the first half of the story though, because the second half came after launch, where they had many times their expected user adoption. In fact, by the third week, the growth was exponential. But because it was built with a serverless architecture, it was able to seamlessly scale up to more than 22,000 concurrent requests and process several petabytes of traffic daily without re-architecting the application. The productivity benefits that Mapbox gained by moving to containers on AWS enable its product developers to focus on the runtime characteristic of its application functionality and performance, while a separate team, called a platform team, could independently optimize the underlying container infrastructure cluster and the security and systems management. They also use cloud-native services to develop a cleaner and easier to manage and deploy architecture by separating logging, metrics, and security infrastructure from the front-end application codebase. And finally, they used the use of containers and container management provided by Amazon ECS allowed for a more efficient use of the underlying compute resources, which cut their EC2 compute costs in half and allowed Mapbox to devote more of their resources to creating customer value. When companies are operating in the cloud and need to develop a new capability as part of the delivery of a new business or customer offering, they have an entirely new approach available to them with the cloud. Using one of AWS's 125 plus cloud native services, they can simply begin leveraging advanced service capabilities with an API, as opposed to the traditional approach of software and service acquisition and spinning up hardware and infrastructure, managing HA, monitoring and scalability, and DR. With AWS, you make an API call, and if you need to use more or less than originally planned, you only pay for what you use. There's no more proliferation of one-off software packages deployed in your data center that need to be maintained in perpetuity regardless of the level of utilization. C-SPAN began adopting Amazon's Rekognition, the image and video analysis service, immediately upon announcement at our reInvent user conference. And they built their image recognition service within 3 weeks. And it was able to index against more than 99,000 people a day, and in the process save 9,000 hours of labor a year by simply using an API call. Another example of how the cloud enables the adoption of advanced capabilities, but more focused on supporting the applications you run in the cloud, is my former company, Edmunds Application Container and Failure Prediction Model. There's lots of cool cloud native uses here, but the two main elements is that it uses data from systems and app logs in the cloud to train models that predict the imminent failure of a container instance. And using cloud native ops management capabilities like auto scaling, the deployed inference model will automatically trigger the removal and replacement of app containers before there is an impact to the user experience. So not only did this reduce the on-call rate by 95%, but it was developed by the Edmunds cloud engineering team that had zero machine learning or data science experience. And we've heard some folks start to call this AI ops. And since we launched the beginning of our serverless framework with AWS Lambda in 2014, customers have not wasted time testing the capabilities of Lambda and achieved massive scale of their critical workloads in the process. So Thomson Reuters processes more than 4,000 requests per second for its product insights real-time analytics dashboard. And FINRA, which regulates the US equities market, performs 500 billion stock validations daily for fraud and anomaly detection. And customers are also learning how to push the limits of the scale offered in the cloud and to develop new capabilities in products for their customers. And one great example is a group of researchers from Clemson University that achieved a remarkable milestone while studying topic modeling, which is an important component of machine learning associated with natural language processing. And they used the Amazon EC2 Spot fleet, which is the available capacity that is not currently being utilized in any particular region at AWS. And in a single region, they were able to spin up 1.1 million virtual CPUs to run their topic modeling jobs in record time. So the Edico genome was able to achieve a world record in their processing of the human genome, and were able to analyze 1,000 human genomes in record time. And they did it at a staggeringly low $3 per whole human genome for the infrastructure cost. Another example of things that previously weren't really realistic prior to a cloud-native architecture in your on-premise data center. And finally, FICO, or Fair Isaac Company, was able to move their decision management suite, which performs machine learning models and for their business-to-business customers, ranging from industries from the insurance, banking, healthcare, manufacturing, and government, in order to help them make decisions on customer offerings. And they were able to move this highly variable workload, which has customers that range from 10,000 requests per day to over 300 million requests per day. And maintaining that infrastructure indefinitely, always on, in order to account for that workload is incredibly costly. So they were able to move their decision management suite to an AWS serverless architecture, and in the process reduce their deployment and operating costs by 95%, because that infrastructure would scale up with the built-in redundancy and availability automatically based on customer requests. And they were also able to move that existing legacy application to a serverless architecture within only a few short weeks. So there are many more examples of customers achieving incredible scale and reinvention with the cloud. And we'd love to have you see more of those by attending our annual user conference called reInvent, which is coming up at the end of November in Las Vegas. And if you'd like to learn more, our team has published a few books, as well as maintaining a pretty robust strategy blog that gets updated a couple of times a week. So I thank you for your time today, and please let me know if you have any questions that we can answer in the Q&A. Thanks very much.